Hey everybody, hope this is reaching you well today. Um, I don't even know what day it is anymore. Um, it is Thursday, March 26th, and it's 11:25 p.m. So I'm going to do these notes for you guys tonight, and then I'll put them on the team. I know some people had problems with the team watching the videos from there, so I'll also put those on the YouTube channel that I made with the other videos, like 1 through 10. So what we've got to do today is the section called Exponential Equations. The stuff that we're going to be doing right now is actually pretty basic. If you have a good understanding of the exponent rules and about common bases, this should be no problem for you. So what we're looking at is we'll have an equation. Your variable is, if you look at all these, is in your exponent. And we're eventually going to use logarithms to help us solve these, but on these particular problems, you don't really need that because these are all going to have a common base. And a common base just means we can write these as the same exact base number. So like our base here is a 3 and our base here is an 81. So if we're looking at those two, can we write those both as a power of the same number? And the answer to that is, of course, yes. We can write these both as a base 3. That is too big. Okay, so this one here on the left is just 3 to the x plus 1. We don't have to do anything with that because that's already in the common base. But the 81 we need to write as a base 3. So 81 is 3 times 3, that's 9 times 3 is 27 times 3 is 81. So that's 3 to the 4th power. So I've taken the left-hand side and the right-hand side, and I've written both of these with a base of 3. Once you do that and the bases exactly match each other, so a 3 and a 3, all you have to do is take your powers and set them equal to each other. So if you say like 3 to the x plus 1 power is equal to 3 to the 4th power, then your x plus 1 has to equal 4. So at this point, it's almost like you can just cancel out your bases and say x plus 1 is equal to 4, and then solve that equation for x. And you just get x equals 3. So what I should be able to do then, when I go back, you can check these. Obviously, I always say this, but not everybody's going to check. But if you take that 3 and plug it in for the x, you'll get 3 to the 3 plus 1, which is 3 to the 4th, and 3 to the 4th is 81. And so you know you did it right. Okay, so on 2, do these have a common base? 2 to a power and 32. Those can both be written as base 2. So this one stays exactly the same. And then 32 is some power of 2. That's 2 times 2 is 4, 8, 16, 32. So that means that this is 2 to the 5th power. There's 5 2's being multiplied. Once these are a match, you can get rid of the 2's and say 2x plus 1 is equal to 5. Solve this equation for x. And get x equals 2. Again, you can go back into the original and do a check. 2 to the 2 times 2 plus 1 power is 2 to the 4 plus 1 power, which is 2 to the 5th power, which is 32. You know your answer is right. Okay, so hopefully those were pretty easy for you. Now that we're looking at problem number 3, this should look a little more complicated. And the reason for that is we can see this left-hand side is written as a fraction and the right side is not. So one thing I want to do with this left side is let's make that into a more manageable number. This is 5 to the first power, but it's in the denominator. Do you remember how we can bring a power up to the numerator? We can do that if we make it 5 to the negative first. So all I'm doing here is I'm taking this 1/5 and writing it as 5 to the negative first, which is equivalent. I still have a 2 minus x exponent on the outside of that. And then my 25, what should I rewrite that as? That's 5 squared. So now what we have to do, we have a power in here, -1, and then we have a power on the outside. If you guys remember from studying exponents in the past, when you have a power raised to another power, these exponents get multiplied. So I have 5 to the -1 times 2 is -2. -1 times a minus x is a plus x. And that equals 5 squared from above in the blue. Now that the bases match each other, these two are the same. I can cross those out, and -2 plus x equals 2. Solve your equation for x, and you get x equals 4. If I go back and check that one, I would have 1/5 raised to the 2 minus 4 power needs to equal 25. So that's 1/5. 2 minus 4 is a -2. When we have a negative power, you just flip the fraction inside and raise it to a positive 2 power. And is 5 squared 25? Yes. So that one checks out also. Okay, so we're just recognizing common bases. Number 4, I see a 9, I see a 3. I can write those both as a base 3. 9 is 3 squared. Leave your original exponent in parentheses. And what is 1 over 3? That's 1 over 3 to the first, or 3 to the negative first. Once you have the same bases, you're going to take your exponents and set them equal to each other. Get the x by itself by dividing both sides by -2, and your x value is a half. So I'm checking, and I just put in 1/2 in for x, so it's 9 to the -1/2. A negative power, remember, moves to the denominator. And then what's a 1/2 power? That's the same thing as the square root. Is the square root of 9, 3? Yes. So that does check out. Okay, on 5, we have, it's a lot going on here on the left-hand side. So I'm going to need to get that all together and combine it. I'm looking for a common base between 2, 8, and 4, and the common base is a 2. So this is 2 to the x. 8 is 2 cubed, or 2 to the third. Keep your original power in parentheses. And then 4 is 2 squared. Keep your original power in parentheses. So I have 2 to the x. I have the 8 is the 2 cubed part, and then the negative x is still there. And then I have 4, which is 2 squared, and then I have still the x from before. The left-hand side here, we have common bases, and we're going to need to do addition on these exponents. If you forget your exponent rules, I always will write out a problem like this, and that would be 2x's and then 3x's. So that's x to the 5th power. So what did I do here? I added the exponents. So that's what I'm going to do here with these. They both have a 2, so I'm going to do 2 to the x plus a negative 3x. And then over here is 2 to the 2x. Once these are down to one common base, that's when I'm allowed to cross out the bases and say x minus 3x is equal to 2x. And I'll solve. So this is like a 1 here. It's negative 2x equals 2x. And then I'm going to add 2x over to the other side. If 0 is equal to 4x, x equals 0. Okay, and then again, that can be plugged back in to your original, and you'll get 2 to the 0. I'll just write that down here. 2 to the 0 power times 8 to the negative 0, which is just 0, and 4 to the 0. So this is 1 times 1 equals 1, which is obviously true. Okay, I've got like 3 minutes, so I'm going to finish number 6 real quick. An 8 and a 16 share a common base. The common base between those two is a 2. This is 1 over 2 to the 3rd. And the 16 is 2 to the 4th. Now, I don't like that on the left-hand side, this one is in the denominator, so I'm going to move that up to the numerator by making it 2 to the negative 3rd. And then keep the 1 minus x in parentheses. So here's your 8. And then to make that go to the numerator, I made it 2 to the negative 3rd. Keep your exponent 1 minus x. And then the 16, we just converted that later. 16 is 2 to the power. And I just copied that down. So now that we have that done, base 2 and base 2 can cancel. So it's negative 3 plus 3x is equal to the 4 on the other side. And I'm going to add 3 to solve the equation. So 3x is equal to 7. Divide both sides by 3. And x equals 7/3. Okay, I'm going to continue on in a new video because I'm like out of time on this one. Bye.